Very good morning. So this is your Raja, working as assistant professor in the Department of Automobile Engineering. So today we'll discuss about the topic exergy, especially in the thermodynamics. So it's a new word in the exergy. So we'll discuss exergy in terms of second law of thermodynamics. So generally we know that first law of thermodynamics and second law of thermodynamics. So the first law, efficiency, so it mainly based on the law of conservation of energy. So that particular conservation of energy is valid whether a process is physically possible or not. The same as if you compare with the second law of thermodynamics. So the efficiency is based on degradation of available energy, that is mainly focusing on quality of energy. Then in the coming to the first law, efficiency can be smaller, equal, or even more than 100%. But while coming to the second law of efficiency, the second law of thermodynamics, always lower than 100%. And again, you may compare in terms of energy conservation. That is energy management on the whole, a first law practice which is necessary but insufficient. So as per first law, energy conservation programs are unnecessary. But coming to the second law of thermodynamics, so the energy conservation should be done with the help of exergy concept. So where exergy is the maximum work which can be obtained from any form of energy, or you can say that useful energy. So that is called exergy. And so mainly we are discussing about the second law of thermodynamics. So what does mean by energy? So that is the combination of exergy and energy. So we know that energy is the capacity of to do work in the energy, and exergy, so ability to do useful work. So then energy is a non-available energy associated with the entropy generation. So in actual process, so exergy is not conserved, but only the energy is conserved. So according to the first law, efficiency of a system and second law, efficiency of a system can be defined as follows. So for coming in the efficiency in terms of first law, that is output by input. So energy out divided by energy in, or desired energy output divided by energy input. And coming with the second law of thermodynamics, the second law efficiency, so the actual performance, that is the exergy out, and to the maximum possible performance is the exergy in. So the second law of thermodynamics, so mainly introduce the concept of exergy. So we may focus on exergy in day-to-day life, how it is related. So if you take the utilization of time, it is not about how much time we have in the first law, and the same time it's about how effectively we use, that is second law of thermodynamics. So you can see that in the first law, utilization of time, how much time needed in the first law, but in the coming to the second law, how effectively we use, so for the time. So that is the utilization of time. And coming to the making experts, so children are born with a different level of talents. So that is, we can say that exergy in different activities, and by uncovering the extent of their talents by aptitude test, and they can be directed towards the area of greatest exergy. If very good talent, you can say that exergy, maximum amount of exergy is available. If the talents are very less, so the exergy is minimum level. So that is the experts in terms of exergy. And coming with the person with the disabilities of high, second law of efficiency. So you can see that the person with the disabilities have low first law efficiency, so that is a lot of input effort, but have high second law efficiency, accomplishing more such as possible under the circumstances. So that is the few concepts related to the exergy in the second law of thermodynamics and how it will be available in the day-to-day life. So coming to the opportunity in daily life, exergy can also be considered as a opportunity that we have, and exergy destruction as the opportunity wasted, or we can say that time is the biggest opportunity we have in our lifespan. So if exergy can be considered as the big opportunity, so that is the we can utilize the energy, and suppose unavailable energy, that is exergy destruction. So in the graph we can see that alertness of a person and his exergy. So we have a high exergy potential and a less exergy potential in the first graph. So we have focusing on studying first. So you can say that x-axis we have the time in hour, and the y-axis mental alertness. So we can see that 0 to 2 hours we have alertness required for study. So and at the same time we have the variation of mental alertness with time. So and coming to the 2 hours to the 4 hours, we can use, or we can go for alertness required for watching TV, and sometimes during this time this alertness is wasted, that is the irreversibility. Okay, in terms of studying first, suppose in terms of watching a movie first, you can see here alertness required for watching TV, and again wasted alertness, that is irreversibility, and alertness required for studying the next 2 to 4 hours. So that is the less exergy potential. If you concentrate, that means if you are concentrating more in terms of studying, that is alertness required for studying, that is high exergy potential. If it is coming to here and watching TV, so that is a less exergy potential. So exergy we may conduct in how the day-to-day life it connected with that. So if you take a exergy of a person, so the exergy of a person at a given time and place can be viewed as the maximum amount of work he or she can do at the time and place. So that is the maximum amount of work can be done, so based on the time and place. So that is the we may consider as the exergy. And suppose it is certainly the difficult to quantify because of the interdependence of physical and intellectual capabilities of a person. So that is also a consider exergy. And again, schooling and training obviously increase the exergy of a person, but aging decreases the physical exergy. So that is connected to our day-to-day life. And unlike most mechanical things, the exergy of human beings is a function of time, and the physical or intellectual exergy of a person goes to waste if it is not utilized at that time. A barrel of oil loses nothing from its exergy if left unattended for 40 years. So that will be wasted. So however, a person lose much of his exergy during the time period he or she just sits back. If you are sitting ideally, so the exergy loss takes place. And again, a hard-working farmer, for example, if you take the physical exergy, but and the farmer use the physical exergy, but very little use of his intellectual exergy. So that is the farmer. For example, could learn a foreign language or a science by listening to some educational CDs. At the same time, he is doing his physical work. So that we may compare with that. And again, that is also true for people who spend considerable time in the car commuting to work. So that is considered as the exergy. So therefore, someday we will be able to do exergy analysis for people and their activities. Such an analysis will point out why the people to minimize their exergy destruction and get more work done in less time. So if we get maximum work with minimum time, so the exergy levels are increasing. And again, the last one is the happiness is closely related to the second law, efficiency. Small children are probably the happiest human beings because there is so little they can do, but they do it so well considering their limited capabilities. That is, children have very good second law efficiencies in their daily lives. So there is a few things regarding exergy. So thank you for your patience.